The method that we use to obtain the probability distribution was the tabulation method, which involves a lot of work. We can get the same result with a relatively simple formula called the Bernoulli formula or Bernoulli trial. The way it works is that the number of outcomes that contain exactly X successes is equal to the binomial coefficient out of n choose X. How does it work? We know that for exactly 2 of the 3 people, we had SSF, SFS, and FSS. We also know that if we analyze the situation for each one of them, it's S times SS squared times F, and we have 3 of them. The probability of success is 0.8 and the probability of failure is 0.2. Now the 3 come from out of 3 choose 2, and that's the binomial coefficient. Remember, out of 3 choose 2 is a combination. Now, probability of success is 0.8, so it's going to be 0.8 squared. And probability of failure is 0.2 times 0.2. And 3 minus 2 is 1. Now, remember that out of 3 choose 2, order doesn't matter, is a combination. So it's going to be 3 factorial divided by 2 factorial times 3 minus 2 factorial. And the answer is 3. So that's where the 3 comes from. Now, times 0.8 squared times 0.2. The answer is 0.384. Here's the way your book solved it. You can stop the video to watch it. P of getting exactly 2 is equal to 0.384. The formula says that P of X equal to X will be out of n choose X, probability of success to the X power, and 1 minus P to the n minus X. And X should be an integer, preferably non-negative, a non-negative integer, meaning that it goes from 0, 1, 2 to n. There's a couple of things that we need to do when trying to find a binomial probability formula. N trials had to be performed, 2 outcomes, success or failure. Trials are independent. The success probability P remains the same from trial to trial. Now, the formula is P capital X equal to X will be equal to out of n choose X, P of X, times 1 minus P, n minus X. Now, for the same problem, we're going to try to find the probability that the number of people alive at age 65 is exactly 2. Well, remember that exactly 2 means that out of 3, you're going to have to choose 2. That's for the number of outcome. Then the probability of success is 0.8 exposed to 2. Multiplied by the probability of failure 0.2 exposed to 3 minus 2, which is 1. Out of 3, choose 2 is equal to 3. 0.8 squared times 0.2 to the first. Now, the answer is 0.384. At most 1, P of at most 1, so it could be 0 and 1. So it's P of capital X equal to 0, which is, out of 3, choose 0, 0.8 to the 0 power times 0.2 to the 3 minus 0, which is 3. So it's going to be, out of 3, choose 0, which is 1, times 0.8 to the 0 power, 1 times, and 0.2 cubed will be 0.008. So the final answer is 0.008. P of capital X equal to 1 will be equal to, out of 3, choose 1, 0.8 to the first power, 0.2 to the 3 minus 1, which is 2, 0.2 to the second power. Out of 3, choose 1 is 3, times 0.8 times 0.04, 0.2 times 0.2. And the answer is 0.096. So at most 1 means P of X less than or equal to 1. So we're going to add 0.008 to 0.0096. The answer is 0.104. At least 1 means X is above or equal to 1, greater than or equal to 1. So we can use the total probability 1 minus the probability that X is strictly less than 1. In other words, X is below 1. And P of X strictly less than 1 is just P of X equal to 0. P of X equal to 0 is 0.008. Therefore, P of X greater than or equal to 1 is equal to 0.992. Determine the probability distribution of the number alive at 65. The different possible outcome that we have are for 0, 1, 2, 3, which represent the number of people alive. We just need to calculate P of X equal to 3, since we've already calculated 0, 1, and 2. Out of 3, choose 3, 0.8 to the third power times 0.2 to the 3 minus 3, which is 0. Out of 3, choose 3 will be equal to 3. And 3 will be multiplied by 0.8 to the third. So P of x equal to 3 is equal to 0.512. Same result as before. And here's a picture of the probability distribution table that we found.